So we're back with hour 3 of our objects and classes lesson. Just want to touch on a couple questions that came up over the break quickly. One of them had to do with, somebody suggested when they were playing around with their lab, Ryan suggested, he said, I put in an integer, but then I tried to give it a really, really large value, and I got an error. Why? Well, the reason is our integer data types, they're not unlimited. They can't hold a number of any size. When we say a number is an integer, that's actually the limit. An integer can only hold numbers between 2.1 million and minus 2.1 million. So if we want to hold a bigger number than that, there's another data type which is called long, and it holds a much, much, much bigger number. So if you're wanting to store numbers in the hundreds of millions or billions, you'll want to use the long data type instead of an INT16 or INT32. The other question that came up about properties was, hey, could we actually change where this button is? Can we change the location? And the answer to that is somewhere in here, yes, it should have one of the properties, and off the top of my head, I'm not sure where. It may be location. There's a left property. So if we want this to be, let's say, 10 pixels from 10 points from the left edge of our screen, we could set it that way. And if we can set the left, we can set the top. If we want to programmatically move that button around, yes, we should be able to do that. Now I get 10 points above and below. So yes, we do have access to the location. Just like with size, we could set height and width. With location, we could set top and left if we want to move things around. We might use this. We'd use this often if we were doing game programming, right? We want things to be moving in our application, moving around or changing where they are. We would constantly be resetting the top and left in order to move something. We could even make it so that when we click it, we reset that top and left, we move it somewhere else. Be something we could do programmatically with our C#. Okay, so I just wanted to come back just to review this again about, because this might be the kind of thing I ask you on a test. What's the relationship between a class and an object? So if we had this here, if we were making cookies, something in here would represent a class and something in here would represent the objects. You got it. So the class is kind of like our model or our template, right? It explains, it defines this is what a cookie is. But this is not a cookie itself. You don't want to eat this, right? So the cookies, the individual cookies, these are the individual objects that are made using that model or that class. So that's the relationship. This is just the definition, and these are the actual things we're making from that definition, okay? And all these slides are on Blackboard in lesson 4. So you can review them at any point. So we've already talked about this stuff. We won't, you'll see these things coming up in Scott's class. So these are some of the HTML objects, some of the HTML tags on a page, and we can treat each one of them like an object. So these would be some of the properties we would have of something like an HTML tag, a class, whether it's enabled or visible. And these are some of the methods that are built into some of the HTML objects. And it's probably by the method names, they're fairly descriptive as to what they do. I think doesn't take much imagination to figure out what does window.open mean or what does window.close mean. Okay. So the syntax is the same. It would be the same when we're working with, so this would be HTML. So it's always the name of our object and then a dot, and then our property name, or the name of our object, a dot, and then our method name. And the methods always have those brackets at the end. So we call this dot notation, and we'll see this in most programming languages. In C#, in JavaScript, in Java, it uses the same syntax when we're talking about objects. Which means it's easy once to understand one language, it's not too hard to then learn another one. So again, we had our dog object before. If we wanted to say our dog is white, we would just assign, give a value to that color property. Or if we want to call a method, we would have the name of the object, dot, and then the method name in brackets. So we'll use that syntax repeatedly. Again, more examples here. I want to just talk a little bit about this. This slide was up there last week, but it's important we review it again because this is what methods will look like in C#. And I wanted to go into a little more detail about what all of these things mean. Okay, and Alex, here was your note about static. There's actually a note. You had asked me the question. We won't worry about that for today. So here was a basic method of what it looks like. So we're going to kind of think about a real world example of what a method looks like in a bit. And we'll kind of break down what these different pieces are and what they mean, even though they're explained here. So I won't read this to you. These are for your own information, but all our methods are going to look something like this. So I want to kind of review and break down exactly what all these things mean because it's all new and probably only one or two of these words make any sense here. I assume the button calculate click makes a bit of sense and everything else is just kind of coding jargon that's unfamiliar to most people. Okay, so we'll kind of think of it this way, right? I actually went out, bought a newspaper today. So it's Ernest, right? Okay, I'm gonna give Ernest the newspaper. So let's think about what we want to do here. We could. So Jesse, if you want a section from the paper, what are you gonna do? So Ernest has a paper. How do you get a section from the paper? Okay, so go and ask him for a section. Yeah, actually go and do it. I actually spent $3 on that newspaper this morning. So tell Ernest which section you want.
There's 4 sections in there.
Yeah, you'll have to unfold it. All right, you can take that back. Okay, Sarah, come get a section of the paper, please. Yeah, there's probably more sections in there. Yeah, that's it. There's your arts. All right. Okay. So that's an example of an everyday action. Let's think about what Ernest and Sarah and Jesse just did. If we were going to code that, add that in C, write that in C#, right? There's some kind of action happening. What would we call that action that was descriptive of what Jesse and Sarah did? Yeah, so get, even more descriptive. What did they get? Write a method, something like get a section. So that's the action we want to perform. And we actually do that every day. I mean, this is usually the first website I go to every day. I brush my teeth, I grab my cell phone off my nightstand, right? So what I just did here is the equivalent of what Jesse just did in the physical world, right? I asked the website to give me a section. Okay. Now, how does the website know? How did Ernest know what section to give Sarah, what section to give Jesse?
Because they specified the section.
Right. You didn't just ask for any section, right? You asked for something specific. So in code, so, and these, many of these things are actually intuitive, right? I said to you, what would you call that method that's descriptive? And you said, Raj, you said get section, that's a description. Well, that's actually, I was thinking that exact same thing because my code sample is exactly, I used exactly the name you mentioned, right? So there's the action we want to perform. Okay. This part in brackets, that's the information that we needed. So before Ernest could give Sarah or Jesse a section of the paper, right, he needed one piece of information, which was what section do you want? And what section do you want? So in our code, anytime we call a method, but we have to provide the method with some information, that part goes in brackets. And there's two names for that. They mean the same thing. So these are called the part in brackets here. This is what's known as a parameter or an argument. So it's information that's coming in when we call a method. So when Jesse called get section, he would have called, what would the value be here for section name? Right, Jesse asked for sports. When Sarah called the same method, she provided a different argument or different parameter. She asked for the entertainment, which the Globe and Mail calls the arts section. Here in blue, we've got this word string. What do you suppose that would be doing? What does that mean? Yeah, so when we're passing information in, the section name, it's what kind of information is it? In this case, it's text, the name of a, right? Those parameters might be something else. Here would be an example of a parameter. Yep, Scott? Sorry, what was it?
Isn't that kind of, I guess this is just me picking on Visual Studio or just C# in general, but why is it that you have to define private as a string and yet get section, you've got a lean string there? Seems kind of redundant, though.
Okay, very good question, because we're coming to this part in a minute. These actually mean two separate things. So this is the stuff in brackets, that's the information that's coming in, right? So in Jesse's case, that was the information sports. In Sarah's case, that information was entertainment. So this is what comes in to the function. Those are the arguments or parameters. This word in front of it means something different. What did, when Jesse and Sarah asked Ernest to perform that action sends something back. What did Ernest give back? Right, so this is the input to the action. Remember we talked about inputs, processing, and outputs? So this is the processing, this is the input. So what does this mean?
Is that not defined a variable?
That is what we've called the return type or the output. So it's what does that method send back?
When would you ever have a situation where you have string before and, let's say integer after?
Good question, and we'll look at that in just a second. It's a very good question, and I'll provide you with the context for that in a minute. Okay, so here's the method, here's the input or the parameter. Then Jesse's case was sports and Sarah's case was arts. And what comes back, this is what Ernest returned to each one of them. In fact, this probably shouldn't be a string. This could even be what it actually came back was a newspaper action. So that's the return type or the output of that function. So just because strings came in, something else might come out. Okay. We'll write another example. So Scott, your question is, why do we need this to be a string? Aren't these always going to be the same? If a string comes in, if text comes in, won't text come out? And the answer is not necessarily. Let's make a new slide. Let's write something, a method like this. I'll make it bigger so we can see. Let's say we're building a shopping cart and we write a function to charge someone's credit card. There's going to be several pieces of information, several parameters or inputs to this method. What information would we need? What would be one thing we would need in order to charge someone's credit card? I'd say there's probably about 4 things we need. Sarah, what's one thing? Okay, so what data type would we use for credit card number? Probably we're going to have an integer for card number. Okay, so that'd be the first thing we need. What else would we need to charge someone's credit card? We need, and what data type is the name?
String.
Yeah, it's going to be a string. What else would we need to know?
Expiration.
Yep. Would that be a string or a number?
That would be date.
Could be a date. The problem with a date is there's something we have on a date that we don't have for the credit card expiry,
Okay.
right? We don't have a day. Could be a month. It could be, yeah, 2 integers, or yeah, or we could do it as a string because it also might start with a 0.
String with a check.
Yeah, so we could do a string for expiry, and we need at least one other input for sure. Yeah, we might need they call it the CVV, so the 3-digit or 4-digit number, and that's always a number, so that's going to be an integer. So they call it CVV. There's one other input we need to charge someone's credit card.
Address?
We might need the type, although the actual card number determines the type, right? If you have MasterCard in Canada, the first 4 numbers will be 5191. So we can actually tell the type. Yeah, how much are we charging, right? If we need to know how much are we billing that credit card. So we need, and what kind of data type would we use for price? Yeah, probably a double because it could be dollars and cents. Method. You couldn't charge anybody's credit card unless you had all of that information. So those are our inputs. So Wilson, I'm coming back to your question. What kind of output, what would we expect this method to return? What kind of value would we want to come back after we try and charge a card with that information for that amount? Yeah, so why might we want it as Boolean?
Because you want yes or no.
Right. If the credit card charge was successful, our method will return a value of true. So in our code, we could save the person's order and show them a receipt and send them an email. What happens if our credit card method, if our charge credit card method returns false? What's our website going to do instead? Yeah, we'll tell the user that the card was the payment didn't go through and ask them to try again. So in this case, our return type would be, our output is a Boolean. To the question then, is there any relationship between the types of inputs we get for a method and the type of output we have? Do they have to be the same? No, right? So the output we get can be completely different from the inputs, whatever our application needs. So in this case, we were asking for a string. I guess in the web case, I ask for a string by clicking on a category name, right? That provides the section name to the Globe and Mail's website. And what do they give me? They give me a whole bunch of text or a string back with all of the content of that section. When I click a different section, I get different text, HTML text back in my browser. So that's really all this stuff here means when we look at our method header. So we're primarily concerned, there's our output or our return type, there's the name of the method we want to run, and these are the inputs or parameters our method needs. Okay, let's try a simple example. Wilson, did I answer your question? Okay. So here's what we want to build. Let's build a new form in Visual Studio. Add a new form to your project. And I want you to put on there 5 buttons. And then above it, 1 label. So your form will look like this. The new form, 5 buttons and a label. So once you have your form and it looks kind of like this, here's what I want you to do next. I want you to use each button, double click on each button, and Visual Studio will write 5 separate click methods, like a button 1 click, a button 2 click, button 3, 4, 5 click. Each time you click the button, I want you to change the message here. So when you click button 1, it should say you've completed 20%. When you click button 2, it should say the same message, but 40%. When you click step 3, that should change to 60, 80, and then when you click step 5, it should say you've completed 100%. So each button you click changes that number, makes it 20%. So when you click this button, you want to change the text on that label to say you've completed 20% of the process. Then you do the same thing on all the other buttons and you just change the number on each one. From 20 to 40, 60, 80, 100. Okay, so you need 5 separate click methods. Okay, that's good. So now do that for the other 4 buttons as well. So you can try this one once you have the machine. Did you install Visual Studio on your laptop already? Okay, so you already have it. So you can do this sample later. Looks nice. So just create a new file. Yeah, so you also need a label. On the form, put a label on up at the top. Grab a label from your toolbox. There you go. Yeah, so just quickly drag it on.
That's not a big trick. I just copied the
So
first
we're
couple
clicking
of
button
buttons.
one.
Changed the button.
Right, so when the user clicks button one, the label should say you have completed 20%. When you click button two, the label should say you've completed 40%. And button 360 button, so you'll have 5 button click methods, and each one changes the text on that label. That's the idea, so just do it on each. Yeah. That's kind of where we're going. We're first going to write it this way, and then we're going to see what happens when we go to make changes, and we're going to make it much more efficient. Okay, good. Okay. All right. Yep, that's it. So just the same code with a different number on each button click. Yep, that's it. Good. Okay, so you've got your buttons. That's good. So we also want to put a label on, so that's where at the top prints it on my screen. I've got to use the label so I can print the message. Just go back to your toolbox. It's right here. Just click right here. Go on. And then you can double click each button. And on each button click, go right to the one line of C# code. Just click step one here. So now you have a button one click. So when the user clicks button one, we want the label text to be you've completed 20%. You're on the right, you just don't, you can take out everything before label one. Delete all that. The rest of it's fine. So you're going to have almost the same line of code repeated 5 times. The only thing is each time the number in it is slightly different. 20% on button 1, 40% on button 2, etc. I'll give you another minute and then we'll walk through this. And then we're going to make a few changes.
If this was like a legitimate program you're making and all that, would you make it so the button you've already clicked is unclickable?
Good point. We could try that.
Or you
Yeah,
make it so you can't click further one until you
Yep.
click one?
we could do that. So I'm going to make a new form here. And I'll just change my program.cs so it loads form 2 instead of form 1. just put on my buttons. And I'll change the default text of my label so when my screen first loads, I'll just have it say click below to start. So when I run my application, beautiful it is not, but that's what it looks like. Now, so far my buttons don't do anything, but there's my interface so far. So I want code to run on the click method of each one of these buttons. So I can double click my first button. So what C# code should I put in here? What should happen when the user clicks the step 1 button?
You complete 20%. So label 1 dot text equals H mark with 1%.
All right, so that's what should happen when they click that first button. I want to change the message on my label. If I run my application again, nothing happens when I click my other buttons. But when I click button 1, that line of C# code executes and my message changes. So now how do I get it, the label to change, to be updated for the other 4 buttons?
Copy, paste that and change it to button 5 and 2 and all the different ones and just change the message on the
Yeah, I could do that. I could also double click each button one at a time, let Visual Studio create the click method. And now I could just copy paste. And then I want to do the same thing with button 3, button 4, and button 5. And each time I'm just going to increase that number by 20%. So there's still no code on 3, 4, 5, but button 1 works and button 2 works. Each time my numbers change. So I can do the same thing now on buttons 3, which will be 60%, and button 4. So we could write these methods ourselves, but it's easier. We'll just let Visual Studio, why write the code when Visual Studio will write it for us just by letting us double click each button. So now we've got 5 methods. Each one does a similar thing, but obviously the text is slightly different in each case. So you can see as I click each time my label changes by 20%. So this is a common thing we might see or do in an application where we're giving the user a series of steps to follow through, and we want to show them how far along they are in the process. You may even see this on Blackboard if you do an online test. As you go through, it will show you how many questions you've answered and how many questions you still have to go. Are there any questions so far about what we're doing here? No. So we've used Visual Studio's built-in methods. We've used the click method of the button. Now, let's say we want to change this message. Okay. So instead of saying you've completed 20% of the process, we want it to say you've completed 20% of this process. So we want to change the word the to the word this. Go ahead and do that in your version. So the word the becomes the word this for all 5 buttons. What do we need to do here in order to make that change?
You just type these words, the
Yeah, we have to type it. How many times do you have to type it?
5, but it's right.
Right, you have to type it all 5 times
Sorry.
or use a find and replace. So I've got to do this.
But you have it. Is there a find and replace function?
There is, yeah, under edit. So if I change my code in 5 different places, now it works, but that wasn't terribly efficient, was it? To repeat that 5 times. So what we want to do now, because we may have to make further changes to this in the future, one of the things we really don't want is we don't want to repeat our code unless we really, really have to, because then changing it is a lot of work to make changes multiple times to basically the same code.
So you could always have the, you have completed this process to be like a string, and then just have that be a bit variable you added later.
That's what we want to do. Instead of all 5 times repeating this instruction, we can actually write our own method. And each button can then execute that one method. So if we want to change that method, we only have to do it once. So let's write our own. So we are going to create our own method that is called from each button. So we'll create the method. Our method doesn't need to return anything. So our return type is void or empty. Our method is just going to take the input, do some processing, and stop. Doesn't send back any values. We'll give our method a descriptive name. We can call it update label. But our method does need a parameter. So what value is different on each button? The button itself, yes. What else is different on each click? Yeah, the actual number. We're going to pass that number into this method. So we'll create it as an integer. And we'll call that %complete. So every time we call this function, we're going to pass in a number and use that number in our output. That's kind of any int will do. We typically use int32 as sort of the standard, but you could use any one of them. So now in here, we want to update our label. So now we're going to take the input, take the number sent from our button, we're going to convert it to a string. So most of our string is static. It doesn't change. Everything in red is the same every time. But the actual number that we want to display will change. When it's clicked from button 1, we're going to send in 20 and we'll display 20. When we click button 2, we're going to send in 40 and we'll display 40 instead. So now we've set up this function, and now we want to change our 5 lines above. So instead of each time it printing out the text, we want to call this method we wrote instead. So I'm going to comment all these lines out. Put 2 slashes in front of them, they turn green. So they're not active code. I run my application right now, I can click the buttons, nothing's going to happen. We've disabled all the code on those buttons. So if I run it, we no longer get messages. Stop my window. So what would we do here? We want now to call our own method when the user clicks button 1. What's the name of the function we want to execute? Yeah, we want to execute our update label function. And when I put in a bracket, Visual Studio tells me what input, what information do you want to send when you execute the update label method. So what value should go here? Yeah, on the first button, we want to send in the number 20. On the second button, we're calling the same function, but instead of 20%, we want it to say 40%. We'll call our function 2 more times. 60% for button 3. 80% for button 4. Now our program should run exactly the same way it did before. Right? We're going to get the same, if you try it now, you're going to get the same result as we got before. So from the user's point of view, they don't see any difference in how these are coded. Right? There's many different ways to get the same results. Step 1, 2, 3, 4, and 5. So both of these are correct. So what's the benefit of our second version where we wrote our own function and we just have this command in here one time?
Better for mass editing.
Okay, let's say we want to change the message again. It says you have, let's change this to say have finished. Right? With our original version, how many changes did we have to make? Right, we'd have to change that code because it was repeated in 5 places. By making this into our own function and calling it from each button, we can just change it in one place, and now all of those buttons will have the new message.
We could also change it using COMP1030.
You could, but again, that's all in one file. It's all in one file, right? We may call this function from many different parts of our application. So now it says finished every time, but we didn't have to repeat that instruction 5 times in our code. So it's much, much easier for us to maintain this code because we're just writing our own function and we're calling it from different places. So both versions are correct, but we'll probably want to use this style of programming instead. Our code is more organized and it's easier for us to update. We haven't duplicated things. Well, we still have duplicated it, we're calling it, but we have less duplication this way. Okay. I'm going to stop our stream for today. That's our time for today. So I'm going to put this solution up on Blackboard, so it will be in here. I'll put it up. It'll say week 4 files, and you can download the entire project and use as your reference. So next week, as I said, please come to class on time. We're having a test right at the start of class. after 8 again, you don't get extra time for the test. Okay, so please be here before 8. I know it's Monday, it's early. That's the time we're all living. Make sure you bring a pen or a pencil. Okay, you're actually going to write this test. So what are we going to talk about? Well, just some basic stuff we've talked about over the first few weeks. What is a variable? What is an object? What's a method? And that you can recognize some basic code structures like this. So that these things are arguments or parameters. This is a method name. Those are the kinds of things I'm going to ask you on the test. Because we need to know what these things are in order to actually write the code. So we've kind of gone slowly. So we'll do that for the first hour of class next week. And then we're going to look at conditions. So when we want our program to behave differently depending on some condition. Like if the user's logged in or not logged in, we'll show them different information or let them do different things. Okay, so that's what we'll do in hours 2 and 3 of next week. Okay.